So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the series of going through some GCSE Maths higher big mark questions taken from some past papers. Now before we get started, as it's always recommended that you have an attempt at these questions before watching this video, and if you haven't got a chance or the facilities to print out the questions, just feel free to pause the videos and read out the question, have an attempt at it and then unpause so you can see what the answer is. Now, looking at these questions in their entirety, they're a mixture of non-calculator and calculator questions. And looking at the questions, you can see that there is some amalgamation of different maths topics merged into one, but those that are there are quite similar. So question 1 looks at Pythagoras, area and surds. Surds 1 there being really the odd one, but again, you probably expect that on a non-calculator paper. Question 2 looks at Venn diagrams with factors and multiples and probability, which if you've practiced Venn diagrams, you'll know that factors and multiples are very common questions. Then you're looking at question 4, area and quadratic solving using the formula, again very common with high mark questions on a calculator paper. Now, if you've not had a chance to print off or have an attempt at this question, I strongly recommend that you pause the video, have an attempt at this question before unpausing as we go through the answer. So looking at this question, it says the diagram shows a right angle triangle and it's got a height of 4 and a hypotenuse of 6. 4 of these triangles are used to make a shaded square as shown. Work out the area of the shaded square. Give your answer in surd form as simply as possible. So for this, to work out the area of a square, we need to know the length of the square. And as you can see, that length is made up from the base of the triangle and taken away from by the height of that triangle. So for this, what we need to do is we need to first of all use Pythagoras to work out what this length here is of the triangle. Now to do that, we're going to need to use Pythagoras because it's a choice between Pythagoras or trig, and there's no angles involved, so it's going to be Pythagoras. So if I label my triangle like so, I need to find a, so a squared equals c squared minus b squared, so that then becomes 36 minus 16 equals a squared, so a squared equals 20, so a equals the square root of 20. Now because we're going to be dealing with surds form, I'm going to simplify that, so that's going to be root 4 times root 5, which is 2 root 5. So looking at this triangle here, if I look at this in its entirety, this whole entire length is 2 root 5. Now to work out the length of the square, this length here, I've got to take away what this length here is going to be, which looking at the above triangle, that's going to be 4. So the length of the square is going to be 2 root 5 minus 4. So then from this, what I can then do is work out the area of the square, which is going to be 2 root 5 minus 4 squared, which is 2 root 5 minus 4, 2 root 5 minus 4 double brackets. Then expanding the double brackets, I get 4 root 25 minus 8 root 5 minus 8 root 5 plus 16. Then if I neaten all of that up, well, this becomes 4 times 5, which is 20. So that becomes 20. This simplified gives me 16 root 5, and I've got plus 16. So then gives me a final answer of 36 minus 16 root 5, and there is my final answer. Moving on to question 2, it says the whole number from 1 to 15 inclusive, so including of 1 and 15, is picked at random. The subset of the Venn diagram includes numbers 1 to 15, and it says that m represents the multiples of 3 and f represents the factors of 24. It says using the Venn diagram, work out which of these probabilities is greater. So the probability of a number being a multiple of 3 given it's a factor of 24, and the number is a factor of 24 given it's a multiple of 3, and you must show your working out. So the first thing we need to do here is using numbers from 1 to 15 inclusive of those numbers, we need to write down all the multiples of 3. So from numbers 1 to 15, that's going to be 3, 6, 9, 12 and 15. if I then write the factors of 24 between the numbers of 1 to 15 inclusive, so that's going to be 1, 2, 3, 4, 6, 8, 12, and that's it, because obviously 24 is not going to be included because it's a number outside of 1 and 15. So then here the other numbers that have not been used are going to be 5, just put a line there, so 5, 7 is not being used, 8, 9, 10 is not being used, 11, 13, 14. So let's fill in this Venn diagram using these numbers. Now, the numbers that go in the middle are the ones that are in the purple list and the green list. So here I've got 3 in both lists, I've got 6 in both lists, and I've got a 12 in both lists. So they're the numbers that are going to be in the middle. So I've got 3, 6, and 12. Now what you want to do in the Venn diagrams to avoid you getting confused is writing the numbers so they look like double digits or triple digit numbers. So try and recognize that they are different numbers. Then in terms of the purple numbers not being circled, that's going to be 9 and 15. And in the green numbers that are not been circled, that's going to be 1, 2, 4, and 8. And the numbers that are going to go outside are going to be 5, 7, 10, 11, 13, and 14. So now what we can do is now work out the probabilities of these events. So looking at this first one, now the given part basically means you're only looking at that circle. So a multiple of 3, so out of the circle of F. So for this first one, I'm only looking at numbers in the F circle. So how many numbers are in that F circle? Well, that's going to be 7. And how many are in that multiple of 3? Well, there's going to be 3. So it's going to be 3 over 7. Then moving on to, I'm just using a different colour, which one we've not used. Let's go for purple. So for the purple one, we're looking for numbers in this circle. So how many numbers are in that purple circle? That's going to be 5. And how many are a factor of 24? Well, that's going to be 3. So the question is asking which of those fractions is bigger. Well, as 3/5 is bigger than 3/7, we can then say that which one is greater. Well, the probability of the number is a factor of 24 given it is a multiple of 3. Moving on to question 3, it says here are 2 similar solids, A and B. The volume of B is 400 centimetre cubed, and is the volume of A approximately 1/4 of the volume of B? So for this, what we need to do, we need to find out which bits of information have we got on each shape. So we've been given the length of 2 corresponding sides of the 2 solids. So here, the length scale factor is going to be 8 over 5, which therefore means that the volume scale factor, and the reason why I'm looking at the volume is because that's the information that's been given, the volume scale factor is going to be 8 over 5 cubed. So, and that equals 512 over 125. So then to work out the volume of A, I'm going to do 400, and because I'm going from big to small, I'm going to be dividing by the volume scale factor, so it's going to be divided by 512 over 125. Now if you wanted to, you could have used 8 over 5 cubed, as long as you make sure that everything's being cubed, both the 8 and the 5, instead of 512 over 125, and that would have been absolutely fine. But if I type that all into my calculator, I get an answer of 97.65625. Now that is approximately, and so what I can then do, I'll move on to that in a second, so that there is the volume of A. So then it then says, is the volume of A approximately 1/4 of the volume of B? Now 1/4 of the volume of B is going to be 400 divided by 4, which is 100. And here, as 97.65625 is approximately 100, the answer is going to be yes. Moving on to question 4, it says the diagram shows a rectangle split into 3 triangles. The total shaded area is 7.5 centimeter cube, squared rather, and it says work out the value of x. Give your answer to one decimal place. So first things first, with any shaded area question, so the shaded area, it's always going to be the big shape, which in this case is the area of the rectangle, minus the area of the small shape, which in this case is the triangle. So I need to work out the area, or an expression for the area of each of these two things. So here the area of the rectangle, which is base times height, and the base is 3, it's going to be 2x multiplied by 3x plus 1. Now at this stage I'm going to leave the brackets as it is, but if you wanted to expand it, that would have been absolutely fine. Then moving on to the area of the triangle, well, that's going to be base times height divided by 2, so that's going to be 2x multiplied by 3x plus 1, all divided by 2, and then I can cancel the 2, which just leaves me with x, 3x plus 1. Now, to work out the shaded area, well, the shaded area is 7.5, so if I just write the SA, which try not to get confused with surface area, is going to be 2x, and then 3x plus 1, take away x, 3x plus 1. Now, we then know that the surface area is 7.5, and if I take those two things away, as it's unfactorized, I can just basically, it's just going to give me a single x, 3x plus 1, because 2x take away 1x, it's just 1x, 3x plus 1, and that equals 7.5. Then if I expand the brackets, I get 3x squared plus x equals 7.5, and you can see now it's slowly started to look like a quadratic equation, so I need to make that equal to 0, which I've done there. Now the fact it says give your answer to one decimal place means that I shouldn't waste any time trying to factorize it, because I'll need to use the formula. So from this, what we then need to use is use the quadratic formula, which if you can't remember you should do. So it's minus b plus minus b squared minus 4ac all square rooted all divided by 2a. So here a equals 3, b equals 1, and c equals minus 7.5. So then working this out, I get x equals minus 1 plus minus 1 squared minus 4 times 3 times minus 7.5 all divided by 2 times 3. And again, if I type that all into my calculator, I'm going to get an answer of, well, I'm going to get two answers. So I'm going to get 1.4, and my other answer is going to be of minus 1.8. Now it can't be 1.8 because you can't have negative length, so x equals 1.4. Then moving on to question 5, it says that this 3D diagram represents a paperweight. The horizontal base ABC is a right angle triangle, CT is vertical, angle ACB is 36 and BC is 13.3 and CT is 9.6. Work out the size of angle between AT and the horizontal base. So the angle that they are wanting me to work out is this angle here. So let's just call that angle A. Now to work out angle A, I need to know what one of the sides of the triangle, this triangle here, is going to be. So I need to find another side, because I need two sides to work out an angle. So I need to work out the hypotenuse of that angle or the base of that green triangle. Now in order to do that, what I need to do is I need to use this triangle here to work out what this length here is going to be. So for starters, what I can then do is I can then work out what this angle, this length here is going to be, so x, and I'm going to do that by using this triangle here, the base triangle. So if I draw that triangle out, just so it's a little bit clearer, this length here is 13.3, here is my right angle, and this angle here is 36 and this is angle X, side X rather. So then labelling the sides, this is going to be the hypotenuse, this is going to be the adjacent, and this is my theta, so I'm going to be using cos. So cos 36 equals X over 13.3, so X equals 13.3 multiplied by cos 36, and if I type that into my calculator, so 13.3 multiplied by cos 36, I get an answer of 10.75992603. Now, commonly students usually ask, what do I need to round this up to? Can I round it up to 10.8? Well, if you round it up, you're going to lose some elements of accuracy. Now, if you're going to round your answer to 1 decimal place, then I would suggest using numbers in between in your working out to maybe 2 or 3 decimal places. But it's entirely up to you. You could also use the exact value. So I potentially would recommend students to go for 10.7560 or 7.6 to maybe an extra decimal place. Alternately, you could just use 13.3 cos 36 and you wouldn't lose any accuracy marks. So it's entirely up to you which one we go for. So now I can swap that X with 10.76 or I can swap it with 13.3 cos 36. Any of those will be absolutely fine. So then if I look at that green triangle now, and let me just draw that again. So here is this green triangle, and we've got this is 9.6, this length here has been 10.76 or 13.3 cos 36, whichever you prefer, and it's angle A that I need to work out. So for this I'm going to use tan, so I've got tan A equals 9.6 over 10.76, I'm going to use that one. So then A is going to equal the inverse tan of 9.6 over 10.76, and if I type that into my calculator I should get an answer of 41.7 degrees, and that's to 1 decimal place. Now if you're writing the answer, always make sure that you do state what you have rounded it to. If there is no mention of any rounding, as you can see there's no mention here, you can basically copy your answer from your calculator and that should be enough to get you the full marks. But it's always good practice if you have rounded an answer to say what you have rounded it to.